Right. Understanding the network address translation policy and security policy configuration. We started this earlier. We went through the presentation and a few things I was trying to write in the whiteboard. Later, I end up in getting some outputs, samples from the internet, and I produce this so that I no need to write and draw, and maybe I'll be drawing some. It reduces time. Okay, so the challenge is the NAT in Palo Alto is not um, same like the NAT that we used to have in the other vendors like Cisco. So there are some considerations, especially when you write the security policy rule to allow the traffic to pass through the firewall. We need to do some considerations. It's not same like what we used to have in the NAT policy rule when it comes to zoning. We have pre-NAT, post-NAT terms that we need to understand here very well. This is before NAT, pre-NAT, after NAT, post-NAT. So why do we need to focus on pre-NAT and post-NAT? So the reason is this. Post-NAT zone is what in the security rule you should have. Whereas in the NAT rule, you will have everything pre-NAT. Before NAT, what was your IP address? Before NAT, what was your zone? Before NAT, what was your port number? It's going to be the same. There won't be any change even for the destination. But when it comes to security policy, the destination zone will be always the postnet. Always the postnet. That's what the main story of this entire chapter. All right. So this one we saw in the previous class. When you're writing a NAT policy, these are the questions that you need to ask. What is the original source address of the computers or the devices that initiates the connection? And what zone that particular address is in? What zone it belongs to? Based on the address, the zone will be identified. And what's the original destination address? And now the destination address and destination zone is going to be the same. And the zone depends on the destination address again. And all these are pre-NAT. The mapped address is going to be the destination zone determining one. So if you're translating to 66.111 in this example, 66.111 belong to internet zone or outside zone. So there will be a big change, but when it comes to security policy, there will be something which we may not know. The destination zone in the security policy, see, the above three is same like what you have in the NAT policy. But the last one depends on the packet where it finally goes. There may be a transit zone. The transit zone will become a destination zone here, but in here it's not going to be the transit zone, it's the final address zone, the final address to which the traffic is getting transferred. For example, the destination NAT. The destination NAT, you will see the destination zone as the final zone, not the intermediate zone. We are going to see a nice example. Now, this one, let me quickly draw a picture. This is, I need a picture in between. So, we got the firewall here, 66.1.1.1, and the internet. And there are computers with the subnet of 10.0, 10. I think 10.1.1.1. Next page we have it, 10.1.1.0. 1.1. Anyone in the subnet. So you got a switch and we got many computers. And this is defined as inside zone. This is defined as outside zone. And the destination, we do not know. Someone we want to reach. It can be anyone. Service also, never mind. Any service. You may be doing telnet or SSH, or you may be doing HTTP, HTTPS. Never mind. On the interface, let's say here it is Ethernet 1/1. The IP address on that interface is this 66.1.1. So now, what is the first question? When you're writing NAT policy, what is the original source address? Okay, the original source address. The source address. Is 10.1.1.1. Now, 10.1.1.1 is in zone inside, so source zone. It may look silly for you when I write, what is this? It's just writing what you see in the picture. But only when you have this clarity, when you do configuration in the GUI, the web GUI, you will not have confusion. So the first question was, what is the original source address? And you know the original source address. Now you also know the original zone from where the traffic originated. That all depends on the address. The source zone is determined. Next, the third question is, what is the original destination address? Destination address is, we don't know. Any, I said, someone. And now, what service? We don't know. Any. Now, to which address you want to translate? This is source NAT. We have two type of NAT we learned. So I'm going to translate this particular address to this interface address by using the third type of NAT. You remember third type of NAT? Dynamic, IP, and port. IP and port, DIPP. So that's the type of NAT that I'm going to pick from the list when I configure in the GUI. And also I'll map this interface. When I map this interface, automatically this address will appear for you. You no need to type this address. Those who did the lab, you can imagine what I'm saying. So this is source NAT. We translate this into this. So the destination translation is going to be nothing. Yeah. Now, this is NAT policy. This is what you should see in the next page. You see the source zone is inside. The source address is this. Okay, anyone in the subnet. We were particular with one particular IP address, 10.1.1.1. Here it is, any, it's okay. And the destination is any. And how do you know what zone? It depends on to which address you map. I'm mapping to 66.1.1.1, which is in the outside zone. That's how my outside zone is determined. The destination zone is outside. See, after this third question, you ask fourth question, what zone is that address in? Which address is the mapped address? It's in outside zone, so I put outside. This is not a destination NAT, this is source NAT. Okay, when it comes to the policy, it's similar question you're going to ask. First question, what is the original source address? This one. So the zone is going to be inside, pre-NAT. And what is the original destination address? Any. Now, after NATing, means after translating to 66, what will be the zone from where the packet will leave outside? After NATing, post-NAT. In this example, these two are same, but not always you will see same. Especially when it comes to destination NAT, you will find different zone. Depends on the final zone in which the packet goes out. Okay, so now we are going to see another topology. You see, I got a computer here. In the same subnet, (10.1.1.0/24) subnet. So this may be .1, .2 computer, and I'm connecting to the firewall, and the zone is inside zone. And then again, I'm going to use the same Ethernet 1/1. The IP address on that is 66.1.1.1. Or let's take some different address. 66. Okay, let it be like that. And I got a server whose address is 66. Let's put public 66.1.1.2. That's the server's public IP address. But this is going to be destination NAT example. So let's keep the server inside. Sorry, so this is not a firewall. This is not a firewall. I'm going to redraw. I'll have DMZ. That's the easiest way to explain this. And I got a server. The server's IP address in DMZ is 192.168.1.100. And the subnet is 192.168.1.0/24. All right, so We got, as usual, internet zone or outside zone. Sorry for scribbling like this. Outside. As usual, we have 66111 on the outside interface. And inside you may have a group of computer 10.1.1.0/24 subnet .1.2. Now our focus is not really inside for the destination NAT. This is an example for destination NAT. Here, internet connected to the outside, and someone here, someone, same like what we saw in the previous example, someone, anyone who wants to access this server should come to this address, let's say 66.1.1.2. This is what the address that I'm going to map. To this server, 192.168.1.100. So anyone who is sending traffic to this one can reach this one. For this, we need to write two policies, NAT policy and security policy. Let's see one by one. Again, the same question we ask, what is the original source address? Any. That's the first question. Second, what zone the source is from? Outside. Third question, what is the original destination address? 66.1.2. That's the original destination address. Okay, now what is the original? What is the zone to which that 66 belong to? Outside. If you see here, the source zone is also outside, the destination zone is also outside. The destination IP is this. So we have answered those 4 questions. What about the source translation? This is destination NAT, so this will be none. And what is the destination translation? That's going to be the address that which I have written here. So this is like a static NAT I'm writing. So the address is going to be 192.168.1.100. This is easy. This is all pre-NAT information that you have given here. And this is what we use as a map address. But to fill these spaces, to fill these inputs in the GUI, we did not use post-NAT. We use pre-NAT. If these things matches, then we need to translate to this address, the destination NAT. There's no problem in the NAT policy while writing, but the focus, the difference comes in the security policy. Same scenario. Let's see here the security policy. Okay, well, let's finish first. This is what we just wrote. Original source is any. zone is outside, and the destination is 6 dot this one 6.1.1.2, and the zone is outside again, and this is the address to which you translate. The source translation none, because we are doing destination NAT. Now same three questions plus fourth question will be based on the final departure from the firewall. So let's ask the same question. Original, this one, original source is any. You see, we are trying to access server 1, which is in the DMZ zone. It's in the DMZ zone, but you don't see that DMZ here when you write the NAT policy. Okay, the original source is the internet zone or the outside zone, and the original destination address is the public address. And now, where is this translation addresses? It's in DMZ. That is what comes as the destination zone. So this is after natting, the destination address will be like this. That's why we call this as post-nat zone. Post-nat zone. After translation, the traffic will be here in DMZ side. It will exit on, that's the final exit, DMZ zone. All right, so this is one scenario. So for what we have seen, inside to outside, which is the source net, and outside to DMZ, which is a destination net. Two things we have seen. Okay, now let us do the same thing with additional policy. This is from outside to DMZ. What if I want to go from inside to DMZ? So what will be the inside subnet? The source. Let's say anyone from inside. Source zone is inside. Anyone from inside wants to access that the same server in DMZ, but he wants to go out. See, according to the firewall, only those who come to this address can go to the server. He cannot go directly from the inside to DMZ. The only option is given is you go to this public address, then he will be translated and taken into DMZ. So the destination IP is 66.1.1.2, which is in the outside zone. Outside zone. Source NAT, none. And again, what is the destination address to which it is translated? It's going to be the same, 192.168.1.1. So here we can see inside to outside NAT policy. Whereas in the above one, outside to outside. Got translated to the same address, it talks to the same server. So this is NAT policy. Now, how will that be when you write security policy? For this, we saw security policy already. Now we are going to see for this one. You see, we just saw this one. Traffic from inside. The source can be anyone in the 10 subnet or any. Get translated to this one, which is in outside, and the mapped address is this, which we just saw. For that, how will the security policy be? This one we early saw. Now we need to fill these places. Tell me if server 1 from inside. Ask those questions that you're supposed to ask. What is the original source address? Any. What is the original zone? Inside. Okay. Now, what is the address to which you translate? This one, 66.1.1. Only then you can go to that server. Okay, what zone it belongs to? That is where the problem is. You cannot write here outside. Though it is in outside, you cannot write here outside. It depends on to which you translate. In the NAT policy, you have said 192.168.1.100, which is DMZ. Right? The application can be web or so. This is not our main focus. So we have written two NAT policy, one for internet people to access the server in DMZ, the other one for inside people to access the same server in DMZ. Both security policy and NAT policy we have covered. Why? Why it is only from outside? See, in our scenario, we don't have any other option to go directly like this. Our policy don't allow you to translate any inside address to DMZ. You don't have permission to do that. They say we already have one translation. Use that to reach this. So we are not supposed to write another translation for this particular DMZ server. Only one address, and that address should be always mapped to 66.1.1.2 only, not to any other 10.1. blah blah. So you come here and then get translated here. Fine. Now, what do you understand here from the previous discussion that we made? In this, what you can understand? If you see, these two can be consolidated. These two, here also outside, here also outside, here also any, here also any. Here also the mapped address is the destination address. Okay, this is destination address. The traffic that comes from inside also it comes to same 66.1.1.2. From outside also it comes to the same address. The mapped address is also going to be the same. Everything is same. Why can't we group it? and it's a static NAT. You see, one-to-one NAT. This address is always translated to this same address. So why can't we group it like this? You see here also, this and this is same, this and this is same, this and this is same, all these are same. So there is an option to group like this. Like this. There's an option where you can say source zone for both inside and outside. Any is the address from inside or outside. If it sends the traffic to this one, which is in the outside zone, then need to get translated to this. So instead of having two separate NAT policy, and two separate security policy, we can write like this. Simple. When you configure, you can focus on this. You can just click that plus sign 2 times. Select that inside and then select outside also. Yes, please. Not really. From outside and inside, you need to have route to reach 66.1.1.2. That's all. Yeah. Because when you come from inside or from outside, your destination address is going to be this only, and source address is going to be one of the address in 10.1.0. So if your testing PC in the inside zone knows how to reach this one, that is enough. And this is going to get translated to this, and firewall knows where this is, and it will push the traffic. Firewall knows the route. Where is that 172.16? Where it is? Is it somewhere here? Is it? Wait. Hold on. That's what I'm trying to do. It is somewhere here. 172.16.1.1. Is it that you are trying to say? Okay, no problem. So now this address is going to be 172.16, but the firewall knows only 192.168.0. network. Let's say 101 is 100. So again, the one who is called as an administrator who designed it know that this router is connected to DMZ. You need to say DMZ only. The mapped address is 172. In this place, you'll be typing 172 instead of 192. And this is going to be DMZ, no change. Because you know, only if I leave, only when I exit via DMZ, I can reach 172, isn't it? You know it clearly. Okay, so let us now move on to the next discussion which we were about to start. That is, instead of having two separate policy, NAT and security, you can consolidate like this. That's what we discussed at last. Why? Because the source and destination, address and zone, mapped address in the destination translation is same in both NAT policy and security policy. Instead of having two separate lines, two separate policy, we can consolidate. That is where we stopped. Now, keep this in your mind and now go to the next paragraph. Next one. Here we are having two servers. We have two servers in the, okay, let me draw this down. In DMZ, now earlier in our topology we had only one server. Now I'm going to have two servers. 192.168. Let's say 1.10, 1.11, two addresses. And now we are going to have a static NAT translation. For 10.168.1.10, I'm going to say 66.1.1.10. And I'm also going to use the same address for both. This is possible in Palo Alto. Static IP is 1-to-1. It's true, but one at a time will be doing the conversation. That's what here it means. So I'm going to give this two just one address. Okay, so internet. Let's say we have some destinations like 24.1.2.3, 208.4.5.6. These are the two different destinations. Now, why do I have this scenario? What is that we are going to learn from here? The issue that is caused by bidirectional NAT, if you see the next page, issue caused by bidirectional NAT rule. When you have bidirectional NAT rule, meaning, you see, bidirectional is said yes. I think I have the picture in another place. So we punched in this, let's say you made a tick mark here. All right, you said bidirectional as an option on static IP. Oh, I closed it. I erased the topology. Sorry, didn't save. Let me quickly draw it again. You got two servers in DMZ. 192.168.1.10 and 1.11. And the address to which you map is 66.1.1.10 in the outside zone. And the destination that you are trying to reach, 24.1.2.3 and 208.4.5.6. I'm trying to match these IP addresses with the next page output. Okay. Now, when we write the NAT rule, we will write like this. Server 1 is the source, right? When server 1 is the source, the IP address is going to be, the source IP address is going to be 192.168.1.10. The source zone is going to be DMZ. That's the second question. And the third question is, what is your original destination IP address? The destination IP address, let's say this guy, A is going to A. This is B, B is going to B. Now, A from DMZ, he goes to A, which is 24.1.2.3. And now that is in a zone. If you want to reach that, if you want to reach the destination, that's in the outside zone. So destination zone is outside. And as we already discussed, we are going to use the static IP, source translation. Source translation, I'm going to translate this to the public IP address because I'm going out now. It's not destination NAT. I'm going from DMZ to outside. In the previous example, it was from outside to DMZ, so we used a destination NAT. Okay, here source translation, static IP, and I'm giving 66.1.1.10, and I'm checking mark that bidirectional, which I showed you. All right. And now, same way for 1.11, destination is 1.11. Sorry, destination for 1.11 is 208, 4.5.6, and the zone is same outside, and this is same. Bidirectionally have enabled. So it's DMC. Right, so this address is different, 208. Here it is 24. The zones are same, source IP address is not same, mapped address is same, and we have check marked that bidirectional. And now there is a problem in this. See, we are trying to understand the issue caused by bidirectional transfer. This is what we just did. Packet is coming from here, from DMZ zone, going to this destination via outside zone. This is the mapped address, static IP, and bidirectional is enabled. Same way, when this comes, trying to go to this destination from DMZ zone via outside, you translate to the same address as above, and bidirectional is enabled. By giving the tick mark here, it is created. So why do we create this? Why do we make a tick mark? Because you don't need to write a reverse NAT. It creates the reverse NAT, which is like what our Girish was saying yesterday. The destination NAT will be created for you. And you say yes here. The reverse NAT, the destination NAT. If traffic comes from here to this address, then it needs to get translated to this. If traffic comes from here to this address, then it needs to be translated to this. That's what we expect. right? We don't see those things in the web GUI. It gets created and you can see it in the CLI, the return NAT policy. NAT policy for the return traffic automatically gets created. But, 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 it is not as per your expectation. What do we expect is, I just explained. I have put it in the next page also. What we expect is, we are expecting this. What? Traffic coming from this to this address, this will be getting translated to this destination net, isn't it? Traffic coming from this to this, get translated. This is what we expect when we click that bidirectional. When we click this to, when we wrote this to, we are expecting that this line will be created for us. Administrator, not things, it is things. Think, things. He thinks that this two lines get created. But the truth is not like this. It is like this. This is what it is going to create. Did you understand this part? Did you understand this part, or should I go a little bit back? I'll go back. Listen, listen. Did you understand this page? This we wrote. When you click on bidirectional, what is bidirectional? Inside to outside? Outside to inside is what the reverse, isn't it? Outside to inside. What is outside source? 24, 1, 2, 3. Is it yes or no? When it comes from outside, what is the source? 24, 1, 1, 1, 2, 3. That's what written here. You see? Right? Now, when it comes from outside, what is the destination? 661110. Yes or no? That's a destination address. Please respond. Yes. That's what you see here. Destination address. Both are in outside zone, isn't it? Source zone and destination zone. Please respond. 24 is also outside, 66 also outside. Yes or no? Now, this is what to which it is going to get translated. See, if this is translated to this, reverse will be what? This to this. Yes or no? Here also it's the same thing written. Only the last address, last server address is different. Do you understand now these two lines? 100%? In this picture itself, I explained that. And now it is also very clearly written here, the same thing. So in short, what I'm trying to say is for the return traffic, you don't want to write NAT policy. So you said yes. You clicked this checkbox, thinking that it will create these two lines for you, at least in CLI. Usually it won't be shown in the GUI. The dynamically written NAT policy will not be shown in the GUI, but you can see in the command line. But when you see in the command line, it will not be actually like this. Instead of source 24, it will have any. Anyone coming from internet Wait, sir. Wait, sir. That is how Palo Alto is designed. That's why they are asking us to learn this. Now, it will it will say any source coming from any zone, coming from any zone, going to this destination, which is in outside, needs to get translated to this. As a result, what happens is when the traffic comes from, because of the NAT statement, this guy and this guy get translated to the same server. The response packet comes to this server. Even that, let me make it clear. So what happens is this guy goes like this here, and this guy goes like this here, but the return traffic is not coming to the right person. It is this comes to this. Because it is said any, even the green, array, it said green. Even the green response comes to this. Why? Because instead of having precise IP address as the source, it is saying any. So this policy will never be matched because here itself it says anyone coming from any zone. If they are coming to this, go to this server. It's sending to only that one server, which is 10.1. So be careful. When you're writing, if you're having multiple servers in DMZ, and when you do static NAT, don't click this yes. Write precisely the reverse NAT also. Don't check mark. Don't check that box. Write it manually like this. You write. If you will have any as an option, anyone to this, only one server you have. You didn't have two servers. You have many zones. Instead of writing one by one by one by one, you just go and click by direction. They all will come and land here. Yeah, because anyone can come here, come into the DM, inside, outside, anyone, any source can come. We won't have like this precise, this guy going to this guy going to. We don't have such scenario in the internet. So to avoid too many lines of dynamic reverse NAT policy, PAN has made it as any. It's not like this. It's going to be like this. Any. So because of this any, all the return traffic will come to server 1, 192.168.1.10. If admin creates two separate NAT rules, this problem will not occur. So for both up and down, you need to write separate policy. Write separate policy whenever you have that one-to-one. Okay, like this. Make a no, put a no, and write outside to outside, go to this. Okay, sorry, this is using PAT. This is using port number. If it is 80, go here. If it is 25 telnet, sorry, SNMP, yeah, you go to this one. Okay, this is sorry, this is not the same scenario. It is here. You write it statically here for the return traffic. Manually, you do. Actually, this should be no because you are writing it manually. The dynamic will say any only. So better you write it manually like this to avoid problem. Period. Okay, this is using port number. What does this says here? Anyone from outside coming to this WAN facing interface address, zone is outside, both the zones. If that port number is TCP 80, then he will be going to this web server in the DMZ zone. If it is 25, then it will be going to another server in the same DMZ zone. Not the same server, different. So this is another example with port numbers. Traffic from DMZ to outside, any source, any destination. Sorry, this source, this destination, sorry, any destination. If it is TCP 123, it okay, this is again talking about using different address for different port number. If this is the source port number, then this is what the address to which it needs to get translated to. This is the port number. This is source NAT. Yes, correct. This first two is source NAT using port number. This is destination NAT using port number. That's what they are trying to show you here. All right, so these are all the considerations